In blast furnace iron making, permeability governs how effectively gas moves through the body. A smooth descent and efficient reaction depend on layer structure and voltage. But when permeability drop, pressure rises, affecting raceway stability, fuel efficiency, and reduction rates. Today's session connects modern design to pressure behavior for smarter furnace control. Here is the reality. Coke has nearly 4 to 5 times the permeability of sinter and pellet. As we know, with a harmonic mean size around 40 mm, coke layers allow gas to pass very easily due to bigger voids. But sinter and pellet layers, especially with harmonic mean size around 14 to 15 mm, resist flow drastically. Since 80% of gas resistance comes from ferrous burden, often we see 75 and 25 distribution is also there. We can say 25 distribution in the granular area and 75 is in the cohesive area. But 80-20 is also very often found distribution pressure losses in the lower and upper zone. Since 80% of the gas resistance comes from ferrous burden, maintaining proper layering becomes mission critical. Because as you must be knowing, if we don't have a proper layering, it further add on this pressure loss and it will be very difficult to assimilate the blast. And unless until we assimilate the blast properly, our specific oxygen consumption cannot be stable, and unless until a specific oxygen consumption value remains stable and consistent, we cannot contribute much on efficiency or utilization of the furnace, and consequently we can say the fuel rate optimization module failed. Now coming to a very important factor, it is very obvious everything is known to operator, but the thing is once we recapture it, recapitulate, we see that how we write the formula, even though that gives a lot of insight about the abnormal situation that we are encountering in the furnace. And it is also helpful in knowing that which factor is contributing and where operator need to focus, where operator need to act preferably, though reasons are various and immense. Many reasons are there. So pressure drop cannot be viewed in isolation. The K factor formula gives us a permeability snapshot across the furnace zones, and everywhere it is all the models or the different AI simulation instruments are working on this basic formula. So partial K value helps pinpoint where flow is obstructed, cohesive zone or dripping zone or upper stack. Though there is a lot of refinement in these DP points in modern units. Modern blast furnaces, a different stages across the vertical height of a stack and Bosch belly region, we tap a differential pressure to measure where we have a resistance like cohesive zone or dripping zone or upper stack, or in even upper stack low temperature breakdown zones or down below that. So it is having a lot of insights on the aerodynamic behavior or assimilation of blast and resistance can be traced with the help of this differential. So fluctuation in differential are linked to also slag holdup, like bottom differential increase. Many times channeling, we do see that there is a sharp shot up of differential, and again coming to the normal position, and accordingly the differential points in that side particularly, the temperatures also synchronize with the differential pressures, so that gives a signal of channeling. And similarly we have got a lot of erratic body and descent that we can visualize across the stock lines, radars movements, or the uptake temperatures, asymmetric conditions can catch hold of such type of erratic body and descent, across which quadrant it can also signal. So operator must monitor and adapt all these signals accordingly, so that he is in position to find out that what is the root cause. So with rising PCA injection, cochlear thin out, and we know that as cochlear thin out, there is a permeability reduction, and there is increase in delta P. Um, Oxygen enrichment also helps in meeting these rise delta P. And as you must be knowing, when we enrich oxygen, uh, at the same time we are replacing, lowering the nitrogen volume, and keeping, this is how we are keeping delta P more stable. So Tuyere velocity changes, pressure conditions, pressure conditions, and so when lesser pressure is lesser volume acceptance is there, V2 changes, and thereafter blast penetration also changes, and once blast penetration changes, then we our utilization also getting tremendously affected. Now, few data has been shared that what is the optimum fuel velocity in Southeast Asia or Euro Union. If we compare, in Southeast Asia operate at around 240 to 260 meter per second. That is, we are planning much more deeper raceway penetration, while US and EU prefer 200 to 220 meter per second to manage the hit load, because in both philosophy, that is Southeast Asia or European Union, in European Union the prolongation of the furnace is very important, and that's why they manage their heat load very precisely, whereas in Southeast Asia they operate around 240 260 for this deep raceway penetration, and with these they keep their Bosch angle accordingly to obtain a higher productivity value. It is all about balancing the stability and thermal control. So to sum up, we can say that um, maintain we must have to maintain the proper burden sizing uh, accordingly. We also have to look into a tremendously this fines optimization. We also must have to confine the undersized fraction that are getting invited due to bad workmanship in the center screening or coke screening. We also need to balance PCI with oxygen enrichment. Monitoring of K value will be of utmost important activity for operators through this level 1 system, or level 2 monitoring is must for this. And we need to have a also guidance or alarming or something uh, color code mapping in order to see that this K value goes beyond the boundary in order to take a corrective action timely. And we need to also see that how we can take control of your velocity evenly, stably, and consistently, because this create this managing this control to your velocity is one of the important parameter. And if we could able to control the Tuyere velocity over a long period of time, our stability of the furnace will be capitalized, and any asymmetric condition can be overlooked if we could able to maintain the right Tuyere velocity. So we can say that fuel stability, fuel rate stability also there while controlling this Tuyere velocity properly. So we can say that distribution mastering permeability and delta P is not a just activity, it's not a theory. It is really a daily activity for the furnace survival. It is sort of a must activity, and each operator and blast furnace stove man must have to focus this thing on a very regular basis. A stable flow means a smoother tapping, cleaner slag, and longer campaign life. And in end, we can say it symbolizes the healthy working of blast furnace and in plant totality, we can say.